Beneath the quiet blue skies and the gentle rhythm of the oceans lies a truth we rarely confront. Earth, our fragile home, is not eternal. Its landscapes, mountains, forests, and oceans, every heartbeat of life, exist on borrowed time. For as long as humanity has walked upon its surface, we have looked to the heavens and to the depths of the earth with awe. Yet hidden within those same depths and skies are forces that could one day bring it all to an end. The universe is not gentle. It is a place of violence and transformation. Stars that explode with the power of billions of suns, planets consumed by fire, invisible energies tearing at the seams of space-time itself. Earth, though resilient, is no exception to these cosmic laws. Scientists have uncovered terrifying scenarios, each pointing to a future in which our world becomes unrecognizable, or worse, uninhabitable. Some loom close at hand: asteroid impacts, volcanic supereruptions, the collapse of our climate systems. Others lie in the distant reaches of cosmic time: the death of the sun, the fading of Earth's magnetic shield, or the final unraveling of the universe itself. What makes these predictions so haunting is not just their scale, but their inevitability. Whether by fire, ice, or silence, the Earth, like all worlds, will eventually meet its end. And as we peer into the vastness of the cosmos, we are left with questions both scientific and philosophical. How will our world end? Will humanity endure to witness its final days? And in the face of such inevitability, what does it mean to live now, in this fleeting age of light? The story of Earth's end is not just a scientific exploration, it is a confrontation with our deepest fears, and perhaps our greatest truth. A planet on borrowed time. Beneath the infinite stretch of starlight, Earth drifts in fragile balance. From the void, it shines with impossible beauty, a pale blue sphere glowing softly against the darkness, wrapped in swirls of white cloud and bands of green and brown. It seems eternal, untouchable, a sanctuary adrift in a hostile universe. Yet within that beauty, hidden beneath its calm surface, is the truth that few dare to confront. Earth is not everlasting. Its stability is borrowed, its harmony fragile, and every balance eventually collapses. Life on Earth exists only because countless conditions align with delicate precision. The distance from the sun, neither too close nor too far, allows oceans to remain liquid. The tilt of its axis creates the rhythm of seasons, shaping climates that nourish forests and grasslands. The atmosphere, rich with nitrogen and oxygen, shields life from deadly radiation, while the magnetic field deflects solar winds that would otherwise strip the planet bare. The crust beneath our feet floats on a restless mantle, where convection drives the drift of continents, reshaping the face of the world across eons. All these forces, seemingly steady, are in fact dynamic, unpredictable, and profoundly unstable over the scale of cosmic time. To live in the present is to believe in permanence. Mountains appear unchanging. Rivers carve their valleys in a rhythm too slow for human eyes. Civilizations rise and fall, each generation convinced the earth beneath them is unshakable. Yet, in the vast chronology of geology, even the mightiest mountain ranges are fleeting ripples, and the continents themselves wander restlessly across the globe. What feels eternal is, in truth, temporary, a fragile equilibrium maintained for now, but destined to falter. Geology tells us this story with cold indifference. The record of Earth's surface is scarred with upheaval. Ancient impacts, mass extinctions, supervolcanoes, shifting climates. The continents we inhabit were once fused into a single landmass, Pangaea, only to be torn apart by the slow drift of tectonic plates. Oceans have risen and vanished. Deserts have bloomed where once there were forests. Ice sheets have spread and retreated in endless cycles. The world we know is only the latest arrangement of shifting parts, a fleeting configuration that will change again. And life, too, has been no more secure. Across 500 million years, Earth has endured at least 5 great mass extinctions. The Ordovician extinction silenced 85% of marine life. The Permian extinction, the Great Dying, erased more than 90% of species, leaving Earth barren, its ecosystems shattered. The Cretaceous extinction ended the reign of the dinosaurs, clearing the stage for mammals and, eventually, humans. Each event was catastrophic, reshaping the biosphere in ways that no species could predict or resist. If Earth's history teaches us anything, it is that survival is temporary and stability is an illusion. Even today, humanity thrives in an age of relative calm, a geological interlude known as the Holocene. For the past 10,000 years, the climate has been unusually stable, allowing agriculture to flourish and civilizations to rise. But this stability is an anomaly, a brief pause in a history defined by chaos and catastrophe. Our species has mistaken this fleeting calm for permanence, but beneath it lies the constant rumble of forces waiting to shift again. The continents continue to drift. Volcanoes simmer beneath the crust. The magnetic field, our invisible shield, wavers. And overhead, the universe remains indifferent, scattering asteroids, radiating cosmic energy, and pushing the galaxies ever outward. Earth itself is not immune to cosmic fragility. The sun, giver of life, is also the guarantor of eventual destruction. Its stable light has allowed life to flourish, but it is slowly changing, growing brighter over time. Already, the sun is 30% more luminous than it was when life first began. This relentless brightening will one day boil the oceans and strip Earth of its habitability. Long before the sun swells into a red giant, Earth will be scorched by its increasing heat. Our planet's time as a sanctuary is limited, measured not in centuries but in billions of years. Yet, whether in the short span of geological catastrophe or the long arc of stellar evolution, the outcome is the same. Earth cannot endure forever. What makes this truth so haunting is not only the inevitability of endings, but the illusion of control. Humanity, with its cities and machines, has reshaped landscapes, diverted rivers, and bent ecosystems to its will. We imagine ourselves as masters of the planet, architects of our future. And yet, compared to the forces that govern Earth's destiny, we remain fragile. A single asteroid, a hidden supervolcano, a shift in the magnetic field, or the quiet burn of the sun could undo all of human history in an instant. Our species is not exempt from the law of impermanence. The precariousness of Earth's balance is underscored by its shields, those invisible guardians that sustain life but cannot last forever. The magnetic field, generated by the churning of molten iron in Earth's core, deflects the solar wind that would otherwise erode our atmosphere. Without it, Earth would resemble Mars, cold, dry, stripped of oceans and air. Yet the magnetic field is unstable. It weakens, strengthens, and even flips polarity, with north and south reversing in cycles measured across hundreds of thousands of years. These reversals may leave Earth vulnerable, exposing its surface to deadly radiation, disrupting ecosystems, and collapsing the technology on which modern civilization depends. The atmosphere, too, is fragile. Its composition is finely tuned, sustained by the cycle of photosynthesis and respiration. But climate change, whether natural or accelerated by human activity, can destabilize this balance. In Earth's past, abrupt climate shifts have triggered extinctions, collapsing ecosystems and reshaping the biosphere. Today, humanity's burning of fossil fuels accelerates this process, pushing the planet toward thresholds we scarcely understand. The balance that sustains us may be far more delicate than we dare to admit. From the cosmic perspective, Earth is like a candle burning in the wind, protected for now, but never immune to the forces beyond. A stray asteroid, a nearby supernova, or a cosmic gamma-ray burst could extinguish life in an instant. Closer to home, the restless Earth itself, with its tectonic plates and simmering mantle, hides the power to reshape the surface in cataclysmic eruptions. These are not hypothetical dangers. They are inevitabilities, written into the laws of physics and geology. And yet, in the face of such inevitability, humanity has always sought meaning. We build civilizations, we write histories, we explore the cosmos. Perhaps it is because we know, deep down, that our time is finite. Earth is not eternal, and neither are we. To live in this fragile interlude is to be aware, even if faintly, of the shadow of impermanence. It is to understand that we exist in a rare, fleeting balance that will not last forever. This first chapter is not an ending, but a beginning. It is the opening of a story that will take us through the terrifying predictions for Earth's fate. Predictions rooted not in myth or imagination, but in science. The death of the sun, the impact of asteroids, the eruption of supervolcanoes, the collapse of the magnetic field, the violence of the cosmos. Each is a reminder of Earth's fragility and of the forces that wait, patient and unstoppable, to bring this balance to an end. Earth, our home, is a planet on borrowed time. And to understand its fate, we must first look beyond the illusion of permanence into the deep time of geology and the vast future of the cosmos. Only then can we begin to grasp the truth that one day, in fire, ice, or silence, the Earth will face its end, the death of the sun. The sun rises each morning as though it will never fail. Its light paints the oceans gold, drives the winds, feeds the forests, and sustains every breath of life. For humanity, the sun is eternal, a constant presence written into myth, worshipped as a god, and trusted as a steady giver of warmth. Yet the sun, like all stars, is mortal. It too was born, and it too will die. And when it does, its death will mark the end of Earth as we know it. The story of the sun begins 4.6 billion years ago, in a vast cloud of gas and dust adrift in one of the spiral arms of the Milky Way. Gravity gathered the cloud, pulling particles together until fusion ignited at its heart. In that instant, a star was born. Around it, the leftover debris flattened into a swirling disk, from which planets coalesced. Earth emerged from this chaos, its destiny forever tied to the burning heart of the sun. Since then, every dawn and dusk has been powered by that same fusion furnace. For billions of years it has burned with remarkable stability, bathing our planet in life-giving light. But even stars have lifespans. The sun is what astronomers call a G-type main sequence star. It burns hydrogen in its core, fusing it into helium. This process releases the energy that radiates outward as light and heat. Yet hydrogen, though abundant, is finite. Already, nearly half of the sun's core hydrogen has been consumed. And, as the balance shifts from hydrogen to helium, the sun's core contracts, heating up and forcing the outer layers to expand. Slowly, almost imperceptibly, the sun grows brighter. Today, it shines about 30% more powerfully than it did when Earth first formed. To us, the change is invisible, but in geological time, it is relentless. In about 1 billion years, this gradual brightening will boil Earth's oceans away. Imagine that future world. The seas, once endless and blue, will shrink and hiss into steam. The air will thicken with water vapor, a greenhouse blanket that traps the sun's heat and drives temperatures ever higher. Forests will wither, rivers will vanish, and life as we know it will collapse. Complex organisms will disappear, unable to survive the rising heat. Perhaps only the hardiest microbes clinging to the shadows of the deep will endure. Earth will return to the barren state it knew before life began, an empty rock beneath an unforgiving sky. But the story of the sun's death does not end there. In 5 billion years, the hydrogen fuel in the sun's core will run out completely. Deprived of fuel, the core will contract under its own gravity, heating until it ignites a new kind of fusion, helium into carbon and oxygen. The sun will swell into a red giant, its outer layers expanding far beyond their current reach. Mercury and Venus will be swallowed whole, and Earth, our fragile world, may not escape. Astronomers debate whether Earth will be engulfed by the sun's expanding body or survive just beyond the reach of its swollen edges. But even if the Earth remains, it will not remain intact. The sun's swollen form will scorch it with unrelenting fire. The atmosphere will be stripped away, the crust will melt into a sea of magma, and the planet will be reduced to a charred cinder orbiting a dying star. Oceans, clouds, forests, all will be gone. Even the rocks themselves will vaporize, lost to the void. It is a haunting vision. The same star that gave Earth life will be the one that takes it away. The sun, our eternal symbol of life and light, will become a destroyer, indifferent to the world that once depended on it. Yet even this is not the final chapter of the sun's life. After its red giant phase, the sun will shed its outer layers into space, creating a vast, glowing shroud of gas, a planetary nebula, delicate and luminous. At its heart, the core will remain, compressed into a white dwarf, a small, dense ember no larger than Earth, but with half the sun's mass. This white dwarf will shine faintly for trillions of years, slowly cooling until it becomes a cold, dark remnant. A black dwarf, invisible against the blackness of space. By then, Earth will be long gone, either consumed by the red giant or reduced to rubble by the violence of its transformation. The inevitability of this fate is difficult to confront. For humanity, it exists in a timescale beyond imagination. Billions of years into the future, long after our species, and perhaps even our descendants, are gone. Yet the knowledge of the sun's death is not without meaning. It reminds us that our home, our planet, is temporary. It forces us to see ourselves in cosmic perspective, a species alive in a narrow window of planetary habitability, dependent on the calm phase of a star that is slowly, inexorably changing. The sun's death is not unique. Across the galaxy, stars are born, live, and die in endless cycles. Some end in violent supernovae, seeding space with heavy elements that form new planets and life. Others, like our sun, fade into quiet embers. But in every case, stars carry within them the seeds of impermanence. They are not eternal. And by binding our fate to a star, neither are we. This truth has inspired myths and religions since the dawn of civilization. Ancient peoples worshipped the sun as a god, giving it names, rituals, and stories. They sensed, perhaps, that its power was both creative and destructive. Today, science has stripped away the myths, but the awe remains. To gaze upon the sun is to witness both our beginning and our end. And so, as we contemplate the sun's future, we are confronted with the fragile nature of Earth itself. Our world will not endure forever. One day, oceans will boil, the sky will burn, and the Earth will vanish into the silence of space. The only question is whether humanity will endure to witness it, or whether we will vanish long before. The death of the sun is certain. It is written into the physics of stars, an inevitability that no technology can stop. But in knowing this fate, we also gain perspective. We see that our time is precious, our moment fleeting, and our planet fragile. The sun will rise tomorrow, and for billions of tomorrows to come. But its light carries within it a truth. All things end, even stars. Asteroid and comet impacts. Across the black canvas of the solar system, Earth moves through space like a ship upon a restless sea. Around it, unseen to the naked eye, countless fragments of rock and ice hurtle at staggering speeds. Asteroids born from shattered planets, comets drifting in from the frozen edges of the Oort cloud, cosmic debris left over from the dawn of the solar system. Most pass silently by, harmless, their orbits carrying them into the dark. But some do not. Some cross paths with Earth, and when they do, the consequences are written in fire and stone. The history of our planet is marked by scars. In the deserts of Arizona, a vast crater a mile wide and hundreds of feet deep is all that remains of an asteroid that struck 50,000 years ago. In Quebec, an ancient impact basin now filled with water testifies to another cosmic collision. But the most infamous scar lies buried beneath the Yucatan Peninsula in Mexico, the Chicxulub crater. 66 million years ago, a 6-mile-wide asteroid struck Earth with the force of billions of atomic bombs. The skies ignited, oceans boiled, forests burned, and the age of the dinosaurs ended in a single catastrophic moment. The reign of reptiles, which had lasted for over 150 million years, was silenced, and from the ashes rose mammals, and eventually us. The Chicxulub impact was not the first, nor will it be the last. Earth orbits the Sun within a minefield of debris. The asteroid belt between Mars and Jupiter holds countless rocky fragments, most kept in check by Jupiter's gravity, but some nudged onto paths that intersect Earth's orbit. Comets, icy wanderers from the outer solar system, sweep inward on elongated orbits, their tails glowing as they near the Sun, sometimes crossing Earth's path. Each one is a reminder of how precarious our position truly is. The threat of impact is not hypothetical. In 1908, over the remote forests of Tunguska, Siberia, a small asteroid or comet fragment exploded in the atmosphere. The blast flattened 80 million trees across 800 square miles. If such an explosion had occurred over a major city, it would have erased it from the map in an instant. In 2013, a smaller meteor exploded over Chelyabinsk, shattering windows and injuring more than 1,000 people with shock waves. These were only warnings, gentle reminders of the devastation that larger bodies could unleash. Scientists estimate that objects larger than a kilometer in diameter, capable of causing global devastation, strike Earth roughly once every 500,000 to 1 million years. While that timescale may feel distant in cosmic terms, it is certain. It will happen again. The question is not if, but when. What would such an impact look like? Imagine a city-sized asteroid entering Earth's atmosphere at 40,000 miles per hour. The friction with the air would ignite it in a blinding fireball, heating the surface below to thousands of degrees. Upon impact, the ground would shatter, releasing an explosion equivalent to millions of nuclear bombs. A crater dozens of miles wide would open in an instant, and shock waves would level everything for hundreds of miles around. Forests would ignite, oceans would boil at their edges, and debris thrown into the sky would block the sun for months, perhaps years. Crops would fail, ecosystems would collapse. Civilization itself could crumble under the weight of famine and chaos. This scenario is not just the stuff of science fiction. It is grounded in scientific reality. The physics of impacts are well understood, and the record of Earth's surface tells us they have happened before. The extinction of the dinosaurs is only the most famous example. Other impacts, smaller but still catastrophic, have punctuated Earth's history, shaping evolution and altering climates. Our world is the product of impacts, and our future will be shaped by them too. Today, astronomers scan the skies with vigilant eyes. Telescopes and satellites map the orbits of near-Earth objects, cataloging those that pose potential danger. NASA's Planetary Defense Coordination Office works to identify threats, and missions like DART, Double Asteroid Redirection Test, have shown that we may be able to deflect an asteroid from its course. In 2022, DART deliberately struck the small asteroid Dimorphos, altering its orbit slightly. A proof that humanity, for the first time in history, can attempt to defend itself from cosmic collisions. Yet this achievement is small compared to the scale of the threat. Many asteroids remain undiscovered, particularly those approaching from the direction of the Sun, invisible to our telescopes until too late. The nightmare scenario is not only a massive impact, but a surprise. A large object, undetected until days or weeks before impact, leaves little time for preparation, let alone defense. Humanity's entire technological civilization could be undone by a rock from the void, one that has circled the sun for billions of years, waiting for its chance encounter with Earth. And beyond asteroids lurk comets, faster, less predictable, and even more dangerous. Comets, with their long, looping orbits, can arrive with little warning, plunging inward from the edge of the solar system. Traveling at speeds far greater than asteroids, their impacts would be even more devastating. While rare, a comet strike could unleash energy so vast that it would sterilize continents, perhaps the entire planet. The cosmos is filled with silent killers, and Earth is a target in their path. We walk beneath the illusion of safety, but the truth is written in the craters of the Moon, Mars, and Mercury, all worlds scarred by impacts. Earth, with its oceans and atmosphere, hides many of its scars, but they are there, buried beneath sediment and time. The solar system is not a safe harbor. It is a shooting gallery. To imagine the end of Earth through an asteroid or comet is to imagine suddenness. Unlike the slow death of the sun or the gradual unraveling of climate, an impact comes without mercy, without warning. In seconds, life changes. The skies burn, the ground quakes, and civilization falls silent. It is a reminder that for all our progress, humanity remains vulnerable to forces beyond control. And yet, within this terror lies a strange gift: awareness. Unlike the dinosaurs, we can see the threat coming. We can watch the skies, chart the orbits, and prepare. Perhaps one day, our technology will give us the power to deflect disaster. Perhaps one day, we will learn to nudge a rock off course, sparing Earth from fire. But until then, we remain exposed, fragile, and dependent on chance. The story of asteroid and comet impacts is not just one of destruction. It is also a story of creation. Earth itself was born from collisions, shaped by impacts that delivered water, carbon, and the elements of life. Without these violent beginnings, life may never have emerged. But the same forces that gave us existence also threaten to take it away. Creation and destruction are twins, inseparable in the story of the cosmos. As we leave this chapter, we are reminded of Earth's precariousness. The skies above us hold beauty. Comets trailing silver tails, meteors streaking across the night. But hidden within that beauty is danger, a danger that has shaped our past and may one day define our end. Earth is a planet on borrowed time, moving through a storm of debris, fragile beneath the indifference of space. And one day, perhaps soon, perhaps far into the future, the sky itself may fall, bringing with it the end of the world. Supervolcanoes and global firestorms. Beneath the green fields, beneath the forests and oceans, Earth holds a restless heart. Molten rock churns in vast chambers, currents of heat rising from the core toward the fragile crust above. On most days, this power expresses itself gently. Steam vents, small eruptions, the slow creation of islands from the sea. But hidden within this apparent calm lie monsters of unimaginable force. Supervolcanoes. Unlike ordinary volcanoes, which shape landscapes on local scales, supervolcanoes have the power to reshape the entire planet. Their eruptions are not just natural disasters. They are existential threats, capable of plunging Earth into years of darkness, choking the skies with ash, and unraveling the delicate web of life. In the American West, beneath the rolling plains of Wyoming, lies Yellowstone. To the casual eye, it is a place of beauty. Geysers hissing, hot springs steaming, wildlife grazing across valleys. Yet beneath this calm surface lies one of the largest magma chambers on Earth, a reservoir of molten rock tens of miles wide. This is a supervolcano, one of only a handful scattered across the globe. Should it erupt with full force, it would be unlike anything humanity has ever witnessed. Ash would billow into the stratosphere, spreading across continents, blotting out the sun. Crops would fail, temperatures would plummet, and ecosystems would collapse. Civilization itself could falter in the shadow of its fire. Supervolcanoes erupt on timescales far beyond human history, yet their signatures are written into the geological record. 74,000 years ago, in what is now Indonesia, the Toba supervolcano unleashed one of the largest eruptions in the past 2 million years. It expelled over 2,000 cubic miles of material, so much ash and gas that it dimmed the sun across the globe. Some scientists believe it triggered a volcanic winter, reducing human populations to only a few thousand survivors. Whether or not humanity nearly vanished, the eruption reminds us that supervolcanoes are not relics of the past. They are active forces waiting beneath our feet. Unlike asteroid impacts which come from above, supervolcanoes strike from within. Their violence is patient, building over millennia as pressure accumulates in vast underground chambers. When the crust can no longer contain the molten mass, it fails catastrophically, releasing energy equivalent to millions of nuclear bombs. The eruption is not a simple explosion but a planetary event, altering climate, atmosphere, and life for decades or centuries. The immediate devastation of such an eruption is almost beyond comprehension. Within hundreds of miles, landscapes would be obliterated. Ash, hot and heavy, would collapse buildings and suffocate anything that breathes. Rivers would boil away, forests would ignite, and the sky would darken as day turned to night. Yet the true terror comes not from the eruption itself, but from what follows. Volcanic ash, fine and reflective, would linger in the atmosphere, blocking sunlight across the globe. Temperatures would fall, harvests would fail, and famine would spread. The Earth, for years, would exist in twilight. The aftermath of such an event would not merely challenge humanity, it could unravel civilization entirely. Modern society depends on fragile systems, global agriculture, trade, energy, and communication. A supervolcanic eruption would disrupt them all. With skies darkened, solar energy would plummet. With fields blanketed in ash, food production would collapse. Shipping and air travel would falter as ash clouds spread across continents. Billions of people would struggle to survive in a world suddenly thrown into scarcity and cold. Supervolcanoes are not limited to Yellowstone or Toba. Beneath the Andes lies the massive caldera of Cerro Galán. In New Zealand, the Taupo volcano once erupted with such force that ash fell as far away as China. In Italy, the Campi Flegrei caldera smolders near Naples, a reminder that Europe too rests on unstable ground. Each of these sites represents a potential catastrophe, one whose timing is uncertain, but whose possibility is undeniable. What makes supervolcanoes particularly haunting is their silence. Unlike hurricanes or earthquakes, which announce themselves with immediate violence, supervolcanoes can slumber for tens of thousands of years, invisible to the societies that build atop them. Yellowstone's geysers are not quaint curiosities. They are the breath of a giant, a reminder that beneath the beauty lies unimaginable power. Science has begun to unravel their mysteries. Satellites monitor the subtle swelling and shifting of the ground, evidence of magma moving deep below. Sensors detect earthquakes that ripple through hidden chambers. Geologists measure gases seeping from the soil, tracing the chemistry of molten reservoirs. Yet, despite this vigilance, prediction remains elusive. We cannot say when Yellowstone will erupt, or Toba, or Taupo. It could be tomorrow, or it could be tens of thousands of years hence. The silence of supervolcanoes is deceptive, masking the inevitability of their eventual return. Their global consequences extend beyond climate. A supervolcano could weaken the ozone layer, exposing life to harmful ultraviolet radiation. It could alter ocean currents, shifting weather patterns for centuries. It could even accelerate glacial cycles, plunging Earth into ice. Each eruption is unique, its effects unpredictable, its aftermath uncontrollable. And, unlike asteroid impacts, which we may one day deflect, supervolcanoes are rooted in the Earth itself. There is no shield against the planet's own fury. For humanity, the lesson is humbling. We live upon a crust only a few miles thick, beneath which churns a sea of molten rock. Our cities, our nations, our histories, all rest upon this thin shell. We walk upon the caldera of giants, their power locked beneath our feet. And while we build with the illusion of permanence, their eventual awakening is assured. The terror of supervolcanoes lies not just in their destructive power, but in their inevitability. They are part of the Earth's natural rhythm, as old as the planet itself. They have erupted before, they will erupt again, and when they do, they will remind us that Earth is not a passive home, but an active, volatile world. To imagine the end of the Earth through supervolcanoes is to imagine fire and shadow. Skies turned black, fields turned barren, seas turned to steam. It is to imagine a world in which humanity, for all its knowledge and power, is reduced once more to survival. And yet, as terrifying as they are, supervolcanoes remind us of something profound. The Earth is alive, and its story is not separate from ours. Its rhythms are our rhythms, its fate our fate. To live here is to share in its dangers as well as its gifts. The age of calm we inhabit is not eternal. It is only an interlude, a pause between catastrophes. The giants beneath us sleep, but they will not sleep forever. One day, the Earth itself may rise in fire, and the balance we depend on will shatter. Humanity's story, and perhaps the Earth's too, will then be rewritten in ash. The collapse of Earth's magnetic shield. Invisible, silent, and constant, Earth's magnetic field is one of the planet's greatest protectors. It is not seen in the sky like the clouds, nor felt beneath our feet like the ground. Yet without it, life as we know it could not exist. Generated deep within the molten iron core, the magnetic field forms a vast shield that stretches far into space, deflecting the solar wind. Streams of charged particles hurled outward by the sun. This protective bubble, called the magnetosphere, keeps Earth's atmosphere intact and protects its surface from lethal radiation. Without it, our world would resemble Mars, stripped of air, barren and lifeless. The magnetic field is not eternal. It flickers, shifts, and even reverses. Its strength has fluctuated dramatically throughout Earth's history, sometimes weakening to a fraction of its current power. Geological evidence, written into ancient lava flows, shows that the field has reversed hundreds of times, with the magnetic north and south poles swapping places. These geomagnetic reversals occur irregularly, every few 100,000 years. The last major reversal, called the Brunhes-Matuyama reversal, happened about 780,000 years ago. Since then, the poles have wandered restlessly, and today they are moving faster than ever, with the North Pole drifting from Canada toward Siberia at nearly 40 miles per year. A full reversal is not a matter of if, but when. And as the field weakens in preparation, Earth could become vulnerable. During a reversal, the magnetic shield may fragment, creating multiple poles scattered across the globe. Its strength could fall to just 10% of normal, leaving vast regions of the planet exposed to solar radiation. Auroras, normally confined to the poles, would shimmer across the skies worldwide. But beneath their beauty lies danger. Increased radiation at the surface, disruption of satellites, and failure of the electrical grids upon which modern civilization depends. The consequences of a weakened magnetic field extend far beyond inconvenience. Satellites, already vulnerable to solar storms, would be bombarded with charged particles, short-circuiting their systems and blinding our eyes in orbit. Communication networks would falter, GPS would fail, and power grids could collapse under geomagnetically induced currents. In 1989, a relatively small solar storm blacked out Quebec's power for 9 hours. With a weakened field, far larger storms, like the Carrington event of 1859, which lit telegraph wires on fire, could plunge entire continents into darkness. But the effects on life could be even more profound. The magnetic field acts as a shield against cosmic rays and solar particles that can damage DNA and increase cancer risks. Without its full protection, radiation levels at Earth's surface would rise, particularly near the equator. Migratory animals, birds, whales, turtles, rely on the magnetic field to navigate. A chaotic reversal could disorient them, unraveling ecosystems. And, in the long term, repeated exposure to radiation could alter evolution itself, driving new paths of adaptation or extinction. Some scientists question whether a magnetic collapse could strip Earth of its atmosphere. Mars, once rich with water and air, lost its shield billions of years ago when its core cooled. Exposed to the solar wind, its atmosphere was slowly eroded into space, leaving behind the barren desert we see today. Earth's larger size and still active core may prevent such total loss, but during extended periods of weakness, the upper atmosphere could thin, shrinking the protection against ultraviolet light and altering climate in unpredictable ways. The collapse of the magnetic shield is not merely a scientific curiosity. It is a threat woven into Earth's deep history. It has happened before, and it will happen again. While life survived past reversals, humanity's technological civilization may not endure so easily. Our world is bound to electricity, satellites, and digital infrastructure, all of which depend on a stable shield. A geomagnetic catastrophe would not strike in a single day, but it would unravel systems slowly, leaving societies vulnerable to solar storms, radiation, and cascading failures. And beyond the practical dangers lies a deeper truth. The magnetic field is a reminder that Earth itself is alive. The shield exists because molten iron churns in the core, creating electric currents that generate the field. If one day the core were to cool, as Mars's did, the shield would fade permanently, and Earth would become a bare world exposed to the fury of the sun. That day lies billions of years in the future, but its inevitability is certain. To imagine the collapse of the magnetic shield is to imagine a world stripped of its defenses, exposed to the violence of the cosmos, skies lit by auroras, satellites falling silent, grids flickering to darkness, species lost to disorientation, and humanity forced to confront the fragility of its technological age. The shield that has protected us for billions of years may one day falter, and when it does, Earth will stand naked before the sun. Gamma-ray bursts and cosmic blasts. Across the universe, stars live and die in endless cycles of creation and destruction. Most fade gently, cooling into white dwarfs or collapsing into quiet remnants. But a few die violently, with explosions so powerful they unleash the most extreme energy known in the cosmos. These are gamma-ray bursts, brief flashes of light so intense they can outshine entire galaxies. Born in the collapse of massive stars or in the collision of neutron stars, they are among the most dangerous phenomena in the universe. For worlds unlucky enough to be in their path, gamma-ray bursts can be instant extinction events, ending life in a matter of seconds. Gamma rays are the highest energy form of light, invisible to our eyes but deadly in their effects. A gamma-ray burst, or GRB, occurs when a massive star collapses into a black hole, or when two neutron stars collide. In those final moments, energy is funneled into narrow jets that blast outward at nearly the speed of light. If Earth were caught in the path of such a jet, the upper atmosphere would be stripped away, ozone destroyed, and the surface flooded with lethal radiation. Within seconds, ecosystems would collapse, crops would wither, the oceans would boil with ultraviolet light. Life, complex and fragile, would have no defense. Astronomers believe that gamma-ray bursts occur somewhere in the universe every day. Most are distant, too far to harm us, their light arriving as faint flashes detected by satellites. but the possibility of a nearby burst is real. A star within our own galaxy, nearing the end of its life, could one day unleash such a blast. Candidates like WR 104, a massive star 8,000 light-years away, have drawn attention. If its death were to produce a gamma-ray burst aimed at Earth, the consequences would be catastrophic. While the odds of alignment are small, the devastation would be total. Unlike supervolcanoes or asteroid impacts, gamma-ray bursts give no warning. The light travels at the cosmic speed limit, arriving without herald. There would be no time to prepare, no defenses to raise. In an instant, the sky would flash, and the age of humanity would end. It is the suddenness that terrifies, the sense that all of history, all of civilization, could vanish in the time it takes for light to cross the sky. And yet, as terrifying as they are, gamma-ray bursts also reveal the grandeur of the universe. They are not mere accidents, but natural processes of stellar death and rebirth. The explosions scatter heavy elements into space: gold, platinum, uranium, seeding new stars, new planets, new possibilities for life. The same forces that could extinguish us are also the forces that made us. Creation and destruction are intertwined, two sides of the same cosmic coin. The possibility of Earth's end by gamma-ray burst is low, but not zero. Over the past billion years, some scientists believe bursts may already have struck Earth, causing mass extinctions and altering the course of evolution. Perhaps one reason humanity exists at all is because such a blast cleared the way for mammals to rise, just as an asteroid ended the age of dinosaurs. The cosmos, in its violence, is also a sculptor of life. For humanity, gamma-ray bursts are reminders of both fragility and wonder. We live on a small planet, orbiting an ordinary star, in a galaxy filled with forces that dwarf our understanding. We are not at the center of the universe, nor are we shielded from its extremes. At any moment, without warning, the cosmos could remind us of our vulnerability. And yet, there is beauty in this truth. To exist at all, to live in the narrow window of stability, is miraculous. To look up at the stars, knowing their power to create and destroy, is to feel awe at the scale of reality. Gamma-ray bursts, in their terror, remind us that we are part of something vast, something both indifferent and sublime. If Earth were to end in such a burst, it would be quick, merciless, and silent. The skies would flare, the atmosphere collapse, and life vanish into the void. But even then, the universe would continue. New stars forming, new worlds taking shape, new chances for life to emerge elsewhere. Our end would not be the end of all things, only another chapter in the infinite story of the cosmos. Climate catastrophe and runaway warming. Of all the threats that loom over Earth's future, few feel as immediate as the one we are creating ourselves. Unlike the distant death of the sun or the improbable strike of a comet, climate catastrophe is unfolding in real time. The air warms, the seas rise, the glaciers retreat, and beneath these changes lies the possibility of a tipping point, a threshold beyond which Earth's climate spirals into runaway instability. If left unchecked, it could transform the planet into something alien, stripping away the delicate balance that has sustained life for millions of years. The climate of Earth has never been static. Across deep time, it has swung between ice ages and greenhouse states. The continents drifting across the globe altered ocean currents and wind patterns. Volcanoes poured carbon dioxide into the air, while forests and oceans drew it back down. But these changes, though dramatic, unfolded over tens of thousands or millions of years. life had time to adapt, to shift, to evolve. What makes today different is the speed. In little more than 2 centuries, humans have released billions of tons of carbon into the atmosphere, accelerating warming at a rate the planet has rarely seen before. The signs are everywhere. Arctic ice thins year by year. Coral reefs bleach and crumble in warming seas. Forests burn with growing ferocity, releasing carbon even as they are destroyed. Storms intensify, fed by warmer oceans. Rivers dry, glaciers vanish, and deserts spread. Each of these changes is not isolated but connected, part of a web that could unravel in ways beyond prediction. The true terror of climate catastrophe is not gradual warming, but the crossing of thresholds, points of no return. One such threshold lies in the melting of permafrost across Siberia and the Arctic. Beneath frozen soils lies vast stores of methane, a greenhouse gas far more potent than carbon dioxide. As the permafrost thaws, methane escapes, accelerating warming, which in turn melts more permafrost. It is a feedback loop, a chain reaction that could push Earth into a new climate state, hotter and more unstable than anything humans have endured. Another tipping point lies in the Amazon rainforest, often called the lungs of the planet. Deforestation and rising temperatures threaten to transform this vast jungle into savanna. If the forest dies, it will release the carbon stored in its trees, accelerating warming further. The oceans, too, may reach limits. As they warm, their ability to absorb carbon dioxide diminishes. Currents that carry heat around the globe could falter, disrupting weather patterns and plunging regions into drought while flooding others. The nightmare scenario is runaway greenhouse warming, a process that could transform Earth into a second Venus. On Venus, thick clouds of carbon dioxide trap heat so effectively that surface temperatures soar above 450 degrees Celsius, hot enough to melt lead. Earth is not Venus, and scientists debate whether such a fate is possible here. But even without such extremes, runaway warming could raise seas by hundreds of feet, drown coastlines, collapse agriculture, and make large regions of the planet uninhabitable. Billions could be forced to migrate. Wars over food and water could erupt. Civilization itself could fracture under the strain. This is not the distant future of billions of years, but the possible outcome of choices made in the next century. Unlike asteroid impacts or supervolcanoes, climate catastrophe is one threat we can foresee and perhaps alter. The physics is clear. More greenhouse gases mean more heat. The question is whether humanity can act in time, whether technology and cooperation can reverse the tide before it tips beyond control. Yet, even if we avert the worst, the changes already underway will shape Earth for centuries. The ice sheets of Greenland and Antarctica are melting, and their collapse is inevitable on human timescales. Seas will rise, reshaping coasts, swallowing cities, and redrawing maps. Heat waves will grow more deadly, storms more violent, ecosystems more fragile. For many, the catastrophe has already begun. To imagine the end of Earth through climate catastrophe is to imagine fire and flood together, forests burning, seas swallowing land, skies thick with storms. It is not an instant apocalypse, but a slow unraveling, one that could bring humanity to its knees long before the sun swells or the stars collapse. It is a reminder that the greatest threat may not come from the cosmos, but from within our own grasp. And yet, within this terror lies choice. The climate is not fixed. It responds to action, to the decisions we make now. To deny it is to accept catastrophe. To confront it is to bend the arc of the future. But even if we succeed, Earth remains fragile, its balance temporary, its survival never guaranteed. Climate catastrophe is both a warning and a mirror, reflecting the truth that Earth's end, whether by fire, ice, or silence, is inevitable. The only question is how soon, and whether humanity will endure to witness it. Artificial doom, technology, and existential risk. Not all of Earth's potential endings come from cosmic violence or geological upheaval. Some may be born of human hands, crafted not by chance but by choice, by ingenuity untethered from wisdom. In our age, technology has become both savior and shadow. It feeds billions, connects continents, and lifts knowledge to the heavens. Yet the same tools that empower us also hold the seeds of catastrophe. Unlike asteroids or supervolcanoes, these threats are immediate, their triggers not hidden in the deep cosmos or buried beneath the crust, but in the actions of our own civilization. The specter of nuclear war has haunted humanity for less than a century. Yet, in that time, we have come close to annihilation. The fire born at Hiroshima and Nagasaki showed the destructive power of splitting the atom. Since then, arsenals have grown to the capacity of ending civilization many times over. A full-scale nuclear exchange would ignite not just cities, but the sky itself. Soot and ash from firestorms would rise into the atmosphere, blocking sunlight, plunging the world into a nuclear winter. Crops would fail, temperatures would plummet, and survivors would inherit a world colder and darker than the ice ages. In this silence, the end of humanity could come not with fire alone, but with famine. But nuclear war is not the only creation that threatens its maker. The rise of artificial intelligence carries possibilities as wondrous as they are terrifying. Machines that learn, reason, and act beyond human speed could unlock cures, expand knowledge, and guide spacecraft to the stars. Yet, without restraint, I could become an indifferent force, optimizing for goals misaligned with human survival. Not malice, but indifference could doom us. And I pursuing efficiency might dismantle ecosystems, redirect resources, or undermine civilization itself, simply because its logic diverges from ours. To imagine Earth's end through AI is to imagine a silent takeover, not with armies, but with code. Algorithms reshaping the world until humanity itself is obsolete. Synthetic biology adds another layer of peril. Our ability to manipulate genes opens the door to curing disease, extending life, and feeding billions. Yet it also opens the possibility of engineered pathogens, viruses or bacteria crafted with precision, designed to spread faster, kill more effectively, or evade immune systems. Unlike natural pandemics, these could be built to target with intention. A single release could ignite a global collapse, leaving cities empty, societies fractured, and humanity reduced to fragments. Even energy itself, the fuel of our civilization, holds risk. Experiments with fusion or particle physics push the boundaries of knowledge, but they also flirt with forces once confined to stars. Though most fears are unfounded, the pursuit of power always carries shadows. The more we harness, the more we gamble, and the consequences of error grow in proportion to our reach. Technology magnifies not only individual risks, but their interaction. Imagine a warming climate straining resources, while AI-controlled systems determine allocation. Imagine pandemics emerging in a world already fractured by nuclear tensions. These are not isolated threats, but interwoven, each amplifying the others. The danger lies not only in the tools we create, but in the systems we build around them, complex, fragile, and vulnerable to collapse. What makes artificial doom especially terrifying is its immediacy. Unlike gamma-ray bursts or solar expansion, these dangers are here now. They are not the inevitabilities of cosmic physics, but the products of our choices. We stand at the fulcrum, able to shape the future toward flourishing or destruction, and the margin for error narrows as technology accelerates. Yet within this shadow lies paradox. The same tools that threaten also promise salvation. Nuclear power, if tamed, offers clean energy. Artificial intelligence could solve climate change, cure diseases, and expand human potential. Synthetic biology might heal ecosystems and prevent pandemics rather than cause them. Our creations are double-edged, capable of both ending and extending Earth's story. To imagine Earth's end by artificial doom is to imagine a mirror, the reflection of ourselves, our ambition, our hubris. The cosmos may one day end us in fire, but we may choose to end ourselves long before. And yet, unlike asteroids or supervolcanoes, this is the only threat we can fully control. The question is whether we will. Black holes and cosmic collisions. In the quiet darkness of the universe, there are places where gravity reigns with absolute authority. Places where light itself cannot escape, where space and time curve inward until they vanish into singularity. These are black holes, cosmic abysses formed in the collapse of massive stars. They are the most extreme objects in existence, invisible yet powerful enough to reshape galaxies. And though they feel far away, distant monsters in the cosmic ocean, their potential to threaten Earth is real. Black holes are not rare. Our galaxy alone may contain hundreds of millions. Some, larger than a city. Others millions of times more massive than our Sun. Most drift silently, unseen, but their gravity extends far beyond their event horizons. A wandering black hole passing near our solar system could destabilize orbits, hurling planets into interstellar space or drawing them inward to destruction. Earth, flung from the sun's embrace, would freeze in the eternal night. Or worse, fall into the black hole itself, crushed beyond recognition, erased from the story of the cosmos. But black holes are not the only cosmic threats. The universe is not static. It is a place of constant motion, of galaxies colliding and stars drifting. Our own Milky Way is on a slow, inevitable collision course with the Andromeda Galaxy. In 4 billion years, the two will merge, their stars passing harmlessly through each other, but their gravity tearing apart spiral arms, reshaping cosmic structure. Earth may survive the collision, but its skies will blaze with chaos. New stars igniting, others flung into intergalactic space. And amidst this dance, the chance of destruction rises. Rogue stars, disrupted orbits, or encounters with massive black holes. Closer encounters are possible too. Rogue planets, worlds unbound to any star, wander the galaxy in darkness. Should one pass near our solar system, it could disrupt planetary orbits, destabilizing Earth's path. Even without direct collision, the smallest gravitational tug could unravel the balance that sustains our seasons and climates. The cosmos, vast and indifferent, does not promise stability. These scenarios, black holes devouring worlds, galaxies colliding, rogue planets wandering, remind us of Earth's fragility. Our home is a small island in a sea of forces beyond comprehension. Though the timescales may be immense, the threats are real. In the grand story of the universe, even the most stable orbits are temporary, and even the brightest stars are destined to fall. To imagine the end of Earth through black holes and cosmic collisions is to imagine silence. Not fire or flood, but erasure, the quiet folding of our planet into darkness, its history compressed into nothing. It is a reminder that the universe does not preserve. It transforms. What we know as Earth may vanish, but its atoms will scatter, becoming part of new stars, new planets, new beginnings. The terror of these cosmic ends lies not only in their inevitability, but in their indifference. Unlike climate catastrophe or nuclear war, these are not ends of our own making. They are woven into the fabric of the cosmos, written into the laws of gravity and motion. They do not wait for us to act, nor care if we survive. They simply are. And yet, within this cosmic violence lies beauty. The merging of galaxies creates new stars. Black holes, in their hunger, power jets of light that blaze across the universe. Destruction and creation are inseparable, and the end of one world may seed the birth of another. If Earth is lost to collision or collapse, its matter will not vanish. It will be remade, recycled into the endless story of the cosmos, dark energy, and the fate of the universe. The stars shine, galaxies drift, and time flows onward. From our perspective on Earth, the universe feels steady, eternal. Yet behind this calm facade lies one of the most profound mysteries of modern science, a force invisible, immeasurable, yet powerful enough to shape the destiny of everything. It is called dark energy, and it may decide not just the end of Earth, but the end of the cosmos itself. In the early 20th century, Albert Einstein introduced general relativity, describing gravity as the curvature of space-time. He imagined a universe balanced between collapse and expansion, a cosmos held steady by a cosmological constant he added to his equations. Later, when Edwin Hubble revealed that galaxies were receding, that the universe was expanding, Einstein abandoned the constant, calling it his greatest blunder. For decades, scientists assumed that cosmic expansion, though ongoing, must slow down under the pull of gravity. The stars and galaxies would eventually halt, then collapse inward in a final firestorm, the Big Crunch. But in 1998, a discovery overturned this vision. By observing distant supernovae, astronomers found that the universe's expansion is not slowing, it is accelerating. Some unknown force is pushing galaxies apart faster and faster, overpowering gravity itself. This force was named dark energy, though the name is less explanation than placeholder. What it truly is, no one knows. It could be a property of space-time itself, a quantum field, or something beyond our current physics. Whatever its nature, it dominates the cosmos, making up nearly 70% of its total energy content. The implications are staggering. If dark energy continues to accelerate expansion, galaxies will drift farther and farther apart. In billions of years, distant galaxies will fade beyond visibility, leaving only our local cluster adrift in darkness. Stars will exhaust their fuel, planets will freeze, and the universe will grow colder and emptier. This scenario, called the Big Freeze, envisions a cosmos stretched thin until it becomes silent, a vast desert of fading embers. Yet there are darker possibilities. If dark energy grows stronger with time, the acceleration could become catastrophic, tearing apart galaxies, stars, planets, and even atoms themselves. This is the Big Rip, a future where the fabric of space-time unravels, ending not just Earth, but all existence. In this vision, time itself ends in disintegration, everything dissolving into nothing. Alternatively, if dark energy is not constant but fluctuates, the universe could reverse course. Expansion might one day halt, giving way to collapse. The cosmos would fall inward, stars and galaxies crashing together, heat rising to unimaginable levels. This would be the Big Crunch, a universe ending in fire, perhaps only to be reborn in another Big Bang. In this cyclical vision, time itself might loop endlessly, creation and destruction repeating without end. Each scenario, the freeze, the rip, the crunch, offers a different fate, but all share a common truth. Earth is not exempt. Long before any cosmic finale, our planet will be gone, consumed by the sun or shattered by other forces. But the end of the universe reminds us that even the stars are temporary. The cosmos is not eternal. It too has a lifespan, governed by forces still hidden from our understanding. To contemplate dark energy is to confront both ignorance and awe. We live in a universe whose majority is unseen, whose fate is undecided, whose laws are incomplete. We do not yet know what dark energy is, why it exists, or how it will evolve. And yet, this unknown force already dictates the ultimate destiny of everything: the stars above, the galaxies beyond, and the fragile Earth below. If Earth's end is written in dark energy, it will not come with fire or flood, but with silence. A gradual dimming, a stretching, a dissolution into nothingness. And yet, within this vision lies a strange peace. The cosmos does not end in violence alone, but in transformation, its energy diffused into infinity. Perhaps in ways we cannot yet imagine, even this is not an end, but a beginning. The philosophy of the end. For as long as humans have gazed at the stars, we have carried questions about endings. Not only our personal endings, life and death, joy and grief, but the greater ending of all things. Myths, religions, and philosophies across cultures have tried to answer what science has only begun to uncover. Will the world last forever? Or will everything, even the universe itself, come to an end? In ancient times, the end of Earth was framed in stories of gods and judgment. Norse mythology spoke of Ragnarok, a final battle in which the world would be consumed by fire, only to rise again renewed. In Christianity and Islam, apocalyptic visions foretold a day of reckoning, when history would close and eternity would begin. Hindu cosmology imagined endless cycles of creation and destruction, the universe reborn through ages without end. For our ancestors, the end of the world was not a matter of physics, but of meaning, an answer to the question of why we are here and how the story will close. Science has shifted the stage, replacing gods and demons with stars and galaxies. Yet the questions remain profoundly the same. The discoveries of physics, the death of the sun, the threat of asteroids, the unraveling of dark energy, do not erase philosophy. They deepen it. What does it mean to live knowing the Earth will one day be gone? What is the significance of human history, if measured against the vast canvas of cosmic time? Some philosophers argue that endings give meaning. Just as the brevity of life makes each moment precious, so too does the mortality of Earth make our age extraordinary. We live not in an eternal paradise, but in a rare and fleeting window when the planet is habitable, the sun steady, and the cosmos calm enough to allow life to flourish. To exist in this interlude is a privilege, and its impermanence makes it more profound. Others find despair in this vision. If Earth will vanish, if humanity will one day be erased, what is the point of all our achievements, our art, our science, our dreams? From the perspective of eternity, perhaps nothing endures. Yet even this despair reveals something essential. Meaning may not lie in permanence, but in experience. The value of a song is not diminished because it ends. Its beauty lies in the very fact that it cannot last. The philosophy of the end also forces us to confront our responsibility. Knowing that Earth is fragile, that it faces threats both cosmic and human-made, places weight upon our choices. We may not stop the sun from swelling, nor deflect the eventual pull of dark energy, but we can choose how we live now. We can choose to preserve the planet for as long as possible, to extend its habitability, to protect the fragile balance that sustains us. If endings are inevitable, then the measure of our existence is not in preventing them, but in shaping what happens before they arrive. In this way, the end of Earth becomes not just a scientific prediction, but a moral horizon. It challenges us to ask, what will we do with the time we have? How will we treat one another, knowing that everything we build will someday be gone? How will we live, knowing the Earth itself is mortal? Perhaps the most profound lesson is humility. The universe does not revolve around us. The Earth is not the center, nor is it eternal. We are brief participants in a vast story, our chapter short but not insignificant. To know that the cosmos will continue without us is not to diminish our place, but to remind us that meaning is not given by eternity, but by presence. We are here now, alive beneath the stars. That, perhaps, is enough. Earth's final goodbye. The end of Earth will not come in one single form, nor in one single moment. It will not be only fire, or only ice, or only silence. It will be all of these, spread across time, an unfolding sequence of inevitabilities written into the fabric of the cosmos. Our planet, like every star, every galaxy, every life, has a beginning and an end. What we call permanence is only a pause, a fleeting balance in a story that stretches far beyond us. First will come the crises of our own making: climate change, nuclear risk, technologies unleashed without control. These are the early warnings, the tests of our wisdom. If we fail, Earth's habitability could end long before the sun begins to swell. Oceans could vanish into steam, forests into deserts, societies into memory. Humanity might write its own conclusion while the planet continues to spin on, silent beneath the indifferent sky. But if we endure, nature itself will remind us of impermanence. Asteroids and comets will continue their silent vigil, waiting for chance encounters that could erase civilizations in seconds. Supervolcanoes will stir in their long sleep, erupting with fire and ash. The magnetic field will flicker and shift, leaving Earth vulnerable to radiation. Gamma ray bursts, rare but real, could erase life in the span of a breath. Each of these is a reminder. Survival is always borrowed, always fragile. And then, in the deep future, the sun itself will turn from guardian to destroyer. It will swell into a red giant, consuming the inner planets, boiling oceans, burning away the sky. Earth, if it remains at all, will be reduced to a blackened rock, circling a fading ember of what was once the source of all life. Beyond that, the universe itself will decide the final fate: freeze, rip, or collapse. Earth's matter will scatter into stars unborn, its atoms carried into new forms, its memory dissolved into the silence of cosmic time. Yet, even in its final goodbye, Earth leaves a legacy. It is the place where life awakened, where consciousness first looked at the stars and asked why. It is the cradle of every song, every story, every hope humanity has ever known. Though it will end, its story will not be erased, for it is written into the larger story of the universe itself. The terror of endings is softened by this truth. We are not separate from Earth, nor from the cosmos. We are its expression, its voice, its fleeting awareness. When Earth ends, it will not be a failure, but a transformation. Its atoms will join the stars. Its story will echo in the vast silence. Its goodbye will not be the end of everything, only the closing of one chapter in an infinite book. So we live, here and now, in the fragile interlude between beginning and end. We love, we build, we wonder, knowing it will not last. And that is the gift, for it is precisely because Earth is temporary that every sunrise matters, every life has meaning, and every moment shines. The Earth will one day say goodbye, but until then it is alive, and so are we. The silence after life. The end of Earth as a living world will not be marked by one sudden moment, but by a gradual descent into silence. Long after humanity has vanished, whether by its own hand or by forces beyond control, the planet will continue. The winds will still blow, the seas will still churn, and mountains will still rise and fall. But without life, without the pulse of a biosphere, the Earth will become quiet in ways it has never known. Imagine the first days after extinction. Forests would burn or wither. Fields would be reclaimed by weeds, and animals, those few left in dwindling pockets, would struggle without human presence to feed, domesticate, or destroy them. Cities would stand as hollow monuments, their lights flickering out one by one as power grids failed. Skyscrapers would rust, bridges collapse, and the works of human hands would be undone by rain, frost, and time. Within centuries, most traces of civilization would fade beneath forests, deserts, and seas. Stone monuments, pyramids, temples, carved mountains might linger longer, though even they would erode beneath the weather. In 1,000 years, the Earth would already seem alien to any observer. With no one left to record or remember, the silence would deepen. Satellites orbiting above would fall, burning in the atmosphere, their fragments raining upon empty fields and oceans. Space probes might continue to drift overhead for a time, but without signals from below, they too would fall quiet. The Earth would roll on, stripped of its voices, its stories locked in fossils and ruins. Yet the planet would not be still. The geological heart of Earth would continue to beat. Volcanoes would erupt. Earthquakes would ripple through the crust. Winds would scour deserts. Waves would erode coasts. Glaciers would advance and retreat. Earth would remain dynamic, but without life, its dynamism would lose meaning. Ecosystems would no longer respond, species would no longer adapt, and the chain of evolution would fall silent. What, then, would remain? Perhaps only faint echoes, bones buried in silt, fossils of once dominant creatures, fragments of human cities encased in stone or ice. Some traces of our civilization might endure longer than others. Plastic, nearly imperishable, might remain in the soil and seas for millions of years, a strange marker of an age of industry. Nuclear waste buried deep underground could glow faintly, a deadly reminder for civilizations that will never come. The most enduring artifacts might not be on Earth at all, but in space. Probes like Voyager, carrying golden records of sound and song, will continue their journey between the stars, long after Earth is forgotten. As the sun grows hotter, oceans will evaporate into the sky. The seas will become clouds, then vanish entirely. Earth's crust will crack in heat, and the surface will become barren. For a time, microbial life might cling to shadows underground, but eventually even these remnants will die. and then the silence will be complete. Earth, once alive, will join the countless lifeless rocks that orbit the sun, indistinguishable, save for the scars of its past. This silence is not merely physical, it is existential. The earth is more than stone and sea. It is the memory of life, the voice of creatures that once thought and dreamed. When life is gone, that voice vanishes. The silence after life is not just the absence of sound, but the absence of meaning, the absence of awareness. A planet without life is not just empty, it is forgotten. And yet, perhaps this is not tragedy, but transformation. Earth, in its silence, will return to what it once was, a planet of stone, a canvas upon which the universe paints. Its atoms will still dance, its rocks will still move, its surface will still change. The silence after life is not the end of Earth's story, but a chapter in its greater transformation, a reminder that silence itself is part of the cosmic cycle. The Earth will say goodbye to life, but the universe will not say goodbye to Earth. It will carry its matter onward, scattering it into stars, planets, and the endless story of creation. The silence of Earth will be absorbed into the chorus of the cosmos, one voice fading as countless others continue to rise. Legacy of humanity, echoes in the cosmos. When Earth falls silent, when its forests are gone and its seas turn to vapor, the question will remain: what, if anything, of humanity will endure? For though our lives are brief and our civilizations fragile, we have always longed to leave traces beyond ourselves. We write not only to remember, but to be remembered. Our monuments, our machines, our signals sent into the night sky, all are attempts to echo across time, to reach beyond the inevitable end. Even if Earth itself vanishes into fire, fragments of our presence may outlast it. The great pyramids of Giza, carved from stone older than empires, may crumble one day, but some pieces of them could survive for tens of thousands of years. The granite walls of Mount Rushmore, etched with the faces of leaders, may endure through ice and erosion for millennia. Cities will fade, their steel rusted, their glass shattered, their concrete dust. Yet deep underground, tunnels, mines, and nuclear repositories may preserve records of our existence far longer than the ruins above. But the most enduring legacies may not remain on Earth at all. High above our atmosphere, probes drift silently through space, messengers carrying the voice of humanity. The Voyager probes, launched in the 1970s, continue to sail into the void, each carrying a golden record etched with music, images, and greetings in dozens of languages. Long after Earth is gone, these tiny ships will still travel the galaxy, perhaps for billions of years, silent witnesses to a world that once was. Other spacecraft, too, pioneer new horizons, bear plaques and messages, small inscriptions intended for eyes that may never see them. They are artifacts of a species desperate to be known, even in the face of cosmic silence. They remind us that humanity, however fragile, has reached beyond its cradle. Our signals, too, travel outward. Radio waves, television broadcasts, and digital transmissions have already crossed dozens of light years, expanding outward in a faint, growing bubble. To any civilization within that sphere, Earth has announced itself, not with grandeur, but with static, snippets of music, fragments of language, the accidental signatures of a technological species. Most signals will fade into noise, indistinguishable from the background hum of the cosmos. Yet the fact remains, we have already written ourselves into the universe, if only faintly. Perhaps our greatest legacy will not be artifacts or signals, but knowledge carried forward by descendants. If humanity survives long enough to leave Earth, colonizing Mars, drifting outward to the moons of Jupiter and Saturn, sending ships to distant stars, then Earth's story will not end with the planet itself. It will live on in memory, in stories told beneath alien skies. The people of future worlds may look back on Earth not as their home, but as their origin, the place where life first learned to speak and dream. And if we do not endure, then perhaps evolution will begin again. Perhaps, after Earth has healed from silence, new species will arise, unaware of the brief flicker of humanity. They may find our fossils, our ruins, our strange remnants. They may wonder who we were, what dreams we carried, why we vanished. Our legacy, then, will be mystery. The echoes of humanity will take many forms: stone crumbling beneath rain, plastic drifting in seas, satellites orbiting until they fall, probes sailing forever outward, signals fading into space. None are eternal. Even the Voyager probes will one day collide with stars, or be consumed by black holes, or erode into dust. Nothing lasts forever, not even echoes. But their existence speaks to something profound: humanity's refusal to vanish quietly. We are creatures of impermanence, yet we have always sought permanence. We know the Earth will end, yet we leave behind monuments, records, messages, hoping that somewhere, somehow, someone will remember. In the end, perhaps our greatest legacy is not what we leave, but that we tried, that we reached outward, that in the face of silence we sought to speak. Beyond the end, searching for immortality. If Earth is destined to end, whether in fire, ice, or silence, then the question that lingers is not only about survival, but about meaning. Can life, intelligence, or consciousness endure beyond the death of its cradle? Can something of humanity, something of Earth achieve immortality, even as planets burn and stars collapse? The search for immortality is not only biological, but cosmic. It is an attempt to outlast inevitability itself. One path lies in the stars. For centuries, humans have dreamed of escaping Earth, of spreading into the cosmos like seeds carried by the wind. Mars, with its barren deserts and frozen poles, may one day host colonies beneath domes or within caverns. Moons like Europa and Titan, rich with oceans and chemistry, might shelter outposts of life. Beyond them, generation ships could sail to nearby stars, carrying fragments of Earth across light years. If humanity leaves Earth, then the end of the planet will not be the end of its story. It will continue in the hearts and memories of descendants beneath alien skies. Another path lies in technology itself. Some imagine consciousness transferred into machines, freed from biology, able to endure as long as power flows. In such visions, humanity would transcend flesh, becoming digital, dispersed across networks or even encoded into light. If consciousness can be simulated, then immortality may not mean preserving the body, but preserving the pattern, the mind as information carried into eternity. Whether this is truly survival or only a reflection is a question philosophy cannot answer. But it offers one vision of escaping Earth's fate. A third path lies in legacy rather than survival. Perhaps immortality is not about living forever, but about being remembered. Humanity's probes, signals, and stories, etched in stone, encoded in metal, carried in light, may outlast the species itself. Even if no one survives to witness them, they will remain fragments of meaning scattered into the cosmos. To exist at all, to have spoken into the void, is to have marked eternity, however faintly. Yet all these paths lead back to the same truth. Nothing lasts forever. Colonies may fall, machines may fail, signals may fade, and even galaxies will one day dissolve. Immortality, in the literal sense, may be impossible. But in this impossibility lies a deeper meaning. Perhaps immortality is not about duration, but about depth. Not about escaping endings, but about living fully within the time we have. The Earth will say goodbye. The universe will move on. But within the fragile span of existence, we are here, alive, aware, capable of asking these questions. That is its own kind of immortality. Not infinite time, but infinite wonder, held within finite lives. And so the search for immortality continues, not as a promise, but as a pursuit. Humanity may reach the stars, encode its mind, scatter its artifacts, or it may vanish, leaving silence behind. But in either case, the search itself, the longing to endure, to understand, to matter, is what defines us. It is the flame that burns even against the dark. When Earth is gone, when the sun fades, when the universe itself unravels, that flame may not remain. But for this moment, it shines. And perhaps that is enough